Good morning, class. Let us start for the next topic for today. In the previous video, we have discussed about the chapter symmetry. What do you mean by symmetry? What is the another name of symmetry? Line symmetry, reflection symmetry. What are the various shapes that follow this symmetric pattern we discussed. Today we will learn alphabets in various methods. First method basically rotation or the symmetry about the line. So let us do. For example, I have written all the letters of the alphabet on the board. Let's see whether they exhibit line symmetry or not. For that, what will we do? Either we'll be having line symmetry in terms of one method is of course horizontal one, and the second one is vertical, correct? So let's see. If I see A as a letter, vertically if I draw a line of symmetry, it is symmetrical in nature. Similarly B, horizontal. Similarly C, horizontal. Similarly D, horizontal. Similarly E, horizontal. Once we move to F, we don't see any symmetry around vertical or horizontal line. That's why F is not having any line of symmetry. Similarly, G is also not having any line of symmetry. But once we move to H, what we see, vertically also it is symmetric and horizontally also it is symmetric. Hence, H is having two lines of symmetry, vertical and horizontal. Similarly, I, if I talk about I, one vertical, one horizontal. So we see two lines of symmetry. But when we talk about J, we don't have any line of symmetry because it is not symmetrical in any context. Let's see K. Yes, absolutely, it's horizontal line. L, it's not symmetrical in any case. N, absolutely vertical. N is not symmetrical in any case, right? Next, O, if I talk about vertical, horizontal. Now you might think O looks like circle. No. O, if I talk about the shape of O, it's ovule shape, not circular. It's ovule shape. That is why O. So when we talk about ovule shape, we'll be having horizontal and vertical. So don't consider O as the circle, and considering circle, don't say that they have infinite line, but they have two. That is vertical and horizontal. That is why O as a letter is having two lines of symmetry, vertical and horizontal. P, no line of symmetry. Q, no line of symmetry. R, no line of symmetry. S, no line of symmetry. T, vertical line of symmetry. U, vertical line of symmetry. V, vertical line of symmetry. W, vertical line of symmetry. X, vertical and horizontal both. Y, vertical line of symmetry, and Z is not having any line of symmetry. Now consider, I have written Y in this form, right? Hence it looks symmetrical. Many times we write Y in this form also. If we write Y in this form, it is not having any symmetry. Do remember. So it depends upon the shape, that what shape exhibits the property of symmetry. That's very, very important. Now let's see how many lines, how many letters we are having. Total we are having 26 letters, right? Out of this 26 letters, how many are having one line symmetry? Let us see one line symmetry. How many of them are having one line of symmetry? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 are having one line of symmetry. Two lines of symmetry. Let us see two lines of symmetry. We are having H, I, O and X. So we are having 4. So total we are having 15 lines of symmetry. Are we clear with this? By this our topic of symmetry is over. Clear with this? By this the topic symmetry, the line symmetry is over. We'll be starting with the next symmetry, that is the point symmetry. Though I haven't discussed the point symmetry with you, but I am giving you an extra purpose about point symmetry. Let's see. Next topic is is point symmetry. What do you mean by point symmetry? When we talk about point symmetry, definitely in case of line symmetry, we need a line to show that there is a symmetry. Similarly, in point symmetry, definitely we'll be having a point to exhibit the symmetry. Therefore, a symmetry or a figure which is symmetrical about a point is known as point symmetry. For example, circle. Circle. If I take a center of a circle, around that point, that circle, if rotates or moves, it will be symmetrical in nature. Are we clear? I'll give you one brilliant example of parallelogram. We know that parallelogram is not having any line of symmetry. Yeah, there is zero line of symmetry in case of parallelogram. Let's say parallelogram, if I'm considering parallelogram, this is a parallelogram A, B, C, D. Now what I'll do, in this parallelogram, I'll draw two diagonals. Okay, this is one diagonal, this is another diagonal. Where the diagonal intersect at this particular point, I'll do one prism, means I'll do one particular path. And about this point, if I rotate this parallelogram, it will be rotating and it will be symmetrical. If I can show you, give me a second, I'll show you how to get it done. Observe it yourself, try to rotate it according to your point. You'll be able to get it. Just observe through this point. If this is a parallelogram, consider this is a parallelogram, and this is the point I have done. If I rotate, just see yourself, it is rotating very clearly. It is rotating very clearly. Very smoothly it is rotating. It will rotate very smoothly. Yeah. But if I change this center to some other center like here, I'll show you one thing. Observe it yourself what will happen. It will not rotate. See, it will not rotate. Can you see what is the difference? Considering herein that we get the point, along this point, this parallelogram seems to be symmetric. But if I do the same point somewhere else, it is not symmetric. It means that a body is having one particular point about which it looks symmetric in nature, and that point is known as point of symmetry. That is why each other object in the nature is symmetric around or across a point. In case of parallelogram, we are having that point where diagonals meet each other. Are we clear? Okay, so this is about point symmetry. That point symmetry, a symmetry across a point or about a point is known as point symmetry. Hence, parallelogram is possessing point symmetry. Are we clear? Next, rotational symmetry. The last symmetry, rotational symmetry. That's very important. Rotational symmetry. Rotational symmetry. Let's see, rotation symmetry. What do you mean by rotational symmetry? What do you mean by rotation? What do you mean by revolution? There are two different concepts, rotation and revolution. Revolution means when you move in a circular path around somebody else. Means, for example, this is one object, this is another object. If this object revolves around this, it means about this object, this particular object is rotating. Hence, it's called revolution. Rotation, when the object rotates about its point. Can you see what is happening? This object is rotating about its point. This is what rotation. Again, I'm repeating, rotation about its own axis. If something rotates about its own axis, that is called rotation. But if something rotates about a point, for example, this is one object, this is another object. If this object rotates around another object, that's called revolution. Clear with this? So here, when we consider rotational symmetry, definitely we'll be considering what? We'll be considering the object rotating about its own axis. So, for rotational symmetry, what is important? We need to rotate an object. Rotate or turn. I told you earlier the three words: folded, flipped, turned, rotate. So here, first thing, we'll rotate an object to have rotational symmetry. Secondly, rotational symmetry basically, we need one important point, that is center of rotation. The three important terms are center of rotation. Next, angle of rotation. Very important. Third point, the order of rotation. What do you mean by angle of rotation, order of rotation? That we will discuss. Center of rotation, about what fixed point you are rotating something. Fixed point about which you are rotating something. That is what the meaning of the center of rotation. Center of rotation, the fixed point about which you will rotate something. Again, my best friend, my parallelogram. I rotated this parallelogram through the center where diagonals were bisecting each other. So can I say this is what center of rotation is? In case of square, let's take the example of square. Yeah, square. For example, A, B, C, D. Diagonals. Diagonals. If I rotate the square where the diagonals bisect each other above this point, it is always in which form? Rotational symmetry. Are we clear? This is called the center of rotation. What we call it as? Center of rotation, the fixed point. We cannot change this point. It has to be the fixed point. Clear? Next, angle of rotation. What do you mean by angle? Angle means the distance between two rays. The distance between two rays is angle. Now, angle of rotation. What do you mean by angle of rotation? Please understand it very carefully. Angle of rotation means at what angle an object or a shape must be rotated so that on rotating that object through that angle, we get the same shape back. Again, I am repeating. Angle of rotation means that angle at which an object must be rotated so that rotating through that particular angle, we get the same object back. That is what angle of rotation. I'll take the example of square only. Let's take the example of square. Observe, square. If I consider the square, each angle of a square, what is square? A quadrilateral or a parallelogram whose each angle is 90 degrees and opposite sides are equal. Like, for example, 90 degree. So, square, what is square? A special type of rectangle whose length is equal to breadth. It means all sides are equal. And each angle is 90 degrees. If I rotate this square through 90 degrees, just see what will happen. Definitely, on rotating it, I'll be getting the square back. Yes or no? But see how it will rotate. I'll show you how it will rotate. On rotating through 90 degree means, for example, object is like this. Rotating 90 degree means object will become like this. Yes or no? So, if I talk about this is 0 degree and this is 90 degree and this is 180 degree, this is 270 degree and this is back to 360 degree or 0 degree. If I keep the object like this, I tilt the object or rotate like this, it means 90 degree. Turning to 90 degree is known as quarter turn. Quarter turn. Are we clear? And returning to 180 degree means half turn. Half turn. So if I turn the object through 180 degree, it means I turn the object in the halfway. Next, if I took 270 as you consider, if I consider 270 degree, it means second quarter turn. Second quarter turn. And reaching back to 360 means full turn. Object return to its original position on turning. Again, 0 original position, 90 quarter, 180 means half turn, 270 if I take this is for example 270 means second quarter, back to 360 means original position. Are we clear? Quarter, half turn, second quarter turn, full turn. Now understand, if I move, there are two ways of moving or rotating object, clockwise and anti-clockwise. So two important words are coming, anti-clockwise and clockwise. What do you mean by clockwise? How does clock move? Clock moves from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 to 1, 1 to 2, it means increasing order. Yes or no? Have you ever heard that 1 o'clock happens before 12 o'clock? Never. After 12 only 1 will happen. That's what. Can we hear it in future that 1 o'clock is happening before 12 o'clock? No. It means that is hypothetical situation which will never happen. That's a fiction, right? Similarly, that is what clockwise. Clockwise means increasing, 12, 1 and all. So if an object moves in this direction, that is known as clockwise. So this direction is known as clockwise direction. Very important. Clear? Anti-clockwise. Anti-clockwise means opposite, reverse. Now what will happen? 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and again back to 12. That is your anti-clockwise direction. Anti-clockwise, clockwise. That's very important. So two important functions are there, clockwise, anti-clockwise. Clear? So 90 degree turn. Now 90 degree turn means, yes, this position. What will happen? This face will go down. It means B, A, C, D. This is 90 degree turn. See, after turning through 90 degree, square is square only, no? Square is square only. Square is remaining square only. Nothing is happening. So can I say angle of rotation of square is 90 degree? Because even after returning through 90 degree, it remains square only. Just see. Again, I am returning or rotating 90 degree. What will happen? Again, what will happen? It is again square only. It is again square only. What will happen now? B, A, C, D. It's 90. 90 plus 90 means 180. 90 plus 90 is 180. Now again if I turn 90 degree, again I will be getting the square back. Again I will be getting the square back. It's B, A, C, D. Yes or no? And again if I return or rotate through 90 degree, again I will be getting the square back. Like for example, it will be A, B, C, D. Don't you think we have retained the original shape? Yeah. And by how many turns? By how many turns or after how many turns we got the same position back? 1, 2, 3, 4. This is called order of rotation. 4. What is order of rotation? After how many rotations we'll be getting the same shape back? That is what order of rotation. But here angle of rotation is 90 degree. If I turn 90 degree, 90 plus 90, 180. After 180 turn, even it is getting square. 180 plus 90, 270 degree. After 270 also, it is square. 270 plus 90, 360. After 360, the full turn, the object will look like the same. Are we clear? So, angle of rotation. I'll give you a brilliant formula, a shortcut to find the angle of rotation. How to find angle of rotation? Angle of rotation formula is equal to 360 degree, because any object in nature, if it takes the complete round, it is 360 degree. 360 upon number of equal sides. Hence we will be able to find the angle of rotation. For example, square. How many sides are equal in square? All the 4 sides. Therefore, 360 degree upon 4, that is 90 degree. That is why after 90 degree is the angle of rotation. After 90 degree, it repeats the same position. If I take rectangle, take the example of rectangle. Rectangle is having 2 shapes. Rectangle is having 2 sides, either length or breadth at a time. So therefore, 360 by 2, 180 degree. That is why for rectangle, the angle of rotation is 180 degree. Are we clear? Now, order of rotation. Order of rotation means how many times, after how many times it repeats. Means order of rotation is equal to number of equal sides. Do remember, order of rotation is equal to number of equal sides. So can you give me an example that if I talk about regular pentagon, what is the order of rotation for regular pentagon? How many equal sides are there for regular pentagon? 5, right? So how many rotations, after how many rotations it will retain the same position back? Of course 5. That is why the order of rotation of regular pentagon is 5. And if we have to find its angle of rotation, that is 360 upon 5. What is that? 72 degrees. 72 degrees is the answer for regular pentagon. Are we clear? So rotational symmetry, center of rotation, order of rotation, all are the parts of this. Now one important thing for you. What do you think any object in nature is there who is not having rotational symmetry? Answer is clearly yes or no, maybe. Understand what it means. Any object whose order of rotation is more than 1. Again I am repeating. Any object in the nature whose order of rotation is more than 1 will exhibit rotational symmetry. Order of rotation equal to 1 means that object after only 360 degree takes the original shape back. In between it will never take the shape back. Best example, quadrilateral, four-sided figure, it will never take. Scalene triangle, it will never take. Parallelogram, I'll give you an example. Parallelogram is an object which exhibits rotational symmetry of order 2 but does not have any line of symmetry. Do remember, very important concept. Are we clear? So to exhibit the rotational symmetry, the order must be greater than 1. Are we clear? If it's equal to 1 means the object after 360 degree only come back to the original position. So it means there is no rotational symmetry throughout. Are we clear with this concept? Rotational symmetry. Any doubt anyone is having with this concept? So rotational symmetry, most important, center of rotation, about a fixed point it should happen. Secondly, angle of rotation, about what angle I must rotate an object so that I get the same shape back. Order of rotation, after how many times we are getting the shape back throughout the whole journey. Whole journey here means 360 degree. 0 to 360 degree. How many times the object is giving or getting or retaining the same position back. That would define your order of rotation. Are we clear about this? So let's do the exercise based on this. Open your book on exercise 14.2. Let's see. Exercise is very simple. First question about the exercises. Let's do the exercise. Which of the following figure have rotational symmetry of order more than 1? Definitely first figure because it's circle. Circle is having infinite symmetries in that case. Triangle, three-sided figure. Three-sided figure means order 3. Definitely 3 equal sides are there. It means order is 3. Third figure. Observe third figure. Here observe. Third figure is like this. If I rotate through 90 degree, it will be like this. On rotating through 90 degree, it will be like this. Again, rotating through 90 degree, it will be like this. Yeah, after 180 it will look like this. So after 180 again, if I rotate like this, how it will look like? It will look like this. And again after 90 degree means 360 degree, it takes back its original position. So what is the order of symmetry for this question, for this figure? It's 360 degree. 360 degree means 1. So we will not consider this shape in the form of order more than 1. Because after 360 degree only, it repeated itself. You might be thinking, sir, but the shape is not changing. The point is not changing the shape, it's retaining back the shape back. Understand, here, these two squares are on the right hand side. But if I consider it is on left hand side. So these are two different shapes. They are not same. They are two different shapes. If I try to put this shape on this shape or overlap this shape, what will happen? It will become like this. Now tell me, are they symmetric? No. Clear? H absolutely, fifth absolutely, sixth absolutely. Now second question, give the order of rotation symmetry for each of the following figure. First figure, answer is 2. Second figure, answer C. The figure is like this. This is 180 degree. Clear? 180 degree. These two lines are intersecting each other. I told you in the previous videos, in lines and angles we discussed, if two intersecting lines are there, definitely this angle and this angles are called vertically opposite angles, and vertically opposite angles are always equal. This is also 80 degree. Clearly, now if this is the line, if this is 80, definitely through linear pair it will be 100. Because what do you mean by linear pair? The sum of two adjacent angles on a line must be 180. So 100 plus 80 is 180. So this is also 100. So if I rotate through any, order is 2. Because after 180 degree turn, this 80 will change, 100 will change. Clear? Next, third equilateral triangle, order is 3. Very simple. 4 blades are there, order is 4. Again, 4 squares are there, order is 4. Pentagon is there, order is 5. Star is there, star is having 6 vertices and center, so that's why order is 6. And line, then 3 again part 3. Clear with this? Next, exercise 14.3. Name any two figures that have both line symmetry and rotational symmetry. Answer is very simple. Square, rectangle, rhombus. 2 lines of symmetry, 2 order of rotation is again 2. So these 3 are the examples. Draw wherever possible a rough sketch of a triangle with both line and rotational symmetry. You know that only one triangle is there which possesses both line and rotational symmetry, that is an equilateral triangle. Now, equilateral triangle, 3 sides are there. Therefore, if I talk about line of symmetry, equilateral triangle, line of symmetry. Now, this is the median, like for example, first, second, third. So it has 3 lines of symmetry. Are we clear? So it has 3 lines of symmetry. If I talk about rotational symmetry, let's talk about, first of all we have to find the angle of rotation. Angle of rotation of equilateral triangle is 360 degree upon 3, that is 120 degree. It means after 120 degree it will rotate back. Yes, after 120 degree if we rotate an equilateral triangle, it will take its shape back. So let us discuss. For example, it is the original shape A, B, C. After original shape, it will take, if I turn it 180 degree, 120 degree, let's see, this is center, this is there, this is there. After 120 degree turn, I am turning 120 degree. The shape will be B, A, C. So it is an equilateral triangle back. Now again after 120 degree turn, it will take the original shape back. For example, again 120 degree, it will take the shape of A, C, B. That's nice. Then again 120 degree, again it will take the original shape back. 120 degree, 120 degree, again 120 degree. It will take A, B, C. So can you see that in case of equilateral triangle, after 1, 2nd and 3rd term, it takes the original shape back. Once it has taken the original shape back, after how many terms? 3. So order of rotation of an equilateral triangle is 3. Are we clear? And angle of rotation, it's 120 degree. So equilateral triangle is the best example here. Okay, next. Question number 2, second part. A triangle with only one line symmetry and no rotational symmetry of order more than 1, that's an isosceles triangle. Isosceles triangle is having one line of symmetry but no rotational symmetry. A quadrilateral with the rotational symmetry of order more than 1 but not a line symmetry. A quadrilateral with rotational symmetry of order more than 1. but not a line symmetry. The answer is parallelogram. Third answer is parallelogram. Next, fourth, a quadrilateral with line symmetry but no rotational symmetry of order more than 1. A quadrilateral with line symmetry, but example I'll take, it's of kite. Let's consider kite. A, B, C, D. Now, what do you mean by kite? Basically, kite is a quadrilateral whose adjacent sides are equal. Adjacent side means these two are adjacent sides. So AB is equal to AD. Next, BC is equal to CD. They are adjacent side equal, therefore it's a kite. If I draw one horizontal line and joining the diagonals, this horizontal diagonal makes it symmetric. Hence, kite is the example which is having line symmetry but no rotational symmetry. Are we clear? Of order more than 1. If a figure has two lines of symmetry, should it have rotational symmetry of order more than 1? Yes, rectangle is the best example. Rectangle is having two lines of symmetry, and also the order of rotation of rectangle is 2 and angle of rotation is 180 degree. Clear? Question number 4, filling the blanks, you have to fill it yourself. Question number 5, name the quadrilaters which have both line symmetry and rotational symmetry of order more than 1. We know square, rectangle, rhombus are the examples. After rotating by 60 degree, about the center, figure looks exactly same as its original position. First of all, the statement means if we rotate an object through 60 degree, after rotating through its 60 degree, it attains its original position same. What it means? It means that 60 degrees angle of rotation for the given figure. For the given figure, angle of rotation is 60 degree. Now tell me which figure is having its angle of rotation as 60 degree. Answer is hexagon, that too regular hexagon. Therefore, a regular hexagon is having 60 degree as the angle of rotation. Clear? Now, after how many rotations it will take position? 6. The order of rotation is 6. Now, first, after 60 degree, it attained its position back. After 60 degree, it attained its position back. Clear? 60 degree, first, add 60 degree, it is 120 degree. Add 60 degree, it is 180 degree. Add 60 degree means 240 degree. Add 60 degree means 300. Add 60 degree means 360. So what is that? The chain is like that. So what are the various angles? After 60, 120, 180, 240, 300, 360. 1, 2, 3, 4, 5, 6. That is why order of rotation is 6. Are we clear? Question number 7. Can we have a rotation symmetry of order more than 1 whose angle of rotation is 45 degree? Now, angle of rotation is 45 degree. Angle of rotation is 360 degree upon n. 45 degree, that is 360. Now upon n. N is equal to 360 degree upon 45 degree. If I cut, I'll be getting 12. I'll be getting 12. It means yes, a 12-sided figure will be having its angle of rotation as 45 degree and order of rotation will be 12. Are we clear? So yes, this particular 45 degree is having rotational symmetry. 17 degree. If I consider 17 degree, 360 by 17 degree, if you divide them, you will not get a perfect natural number. Why I am talking natural number? Why I am not considering whole number? Because if I take side 0, there is no such figure. That is why I am considering natural number. Because natural number 1, 2, 3, 4, 5, 6 and so on up to infinity. Whole number starts from 0. If I count 0 sides, it doesn't mean that. It's irrelevant to consider even. That is why I am considering natural number. Here I will be getting answer in decimal form. Have you ever heard 17.77 sides a figure is possessing? No. For a side, it is a perfect, not even integer, I will say a natural number. Are we clear? With this chapter is over, but let's understand to last definition. I'll consider that last definition. Polygon. First of all, the pronunciation is polygons, not polygons. What do you mean by polygons? First thing is simple closed figure. Very important. Simple closed figure. Secondly, made up of only line segments. So that is very important. that what do you mean by polygons? Polygons, first of all, closed figure. What do you mean by closed figure? Closed figure means starting and ending point should be same. The object must start and end at the same point. For example, if I started from this point and I reached the same point, it means this is closed figure because starting and end point is same. Starting and end points are same. Okay, clear. Next thing, simple. Understand simple. But do you know it is not a polygon? Why? It should be made up of only line segments. This is a curve. Line segment. If I talk about a square, if I talk about a quadrilateral, if I talk about a triangle, if I talk about a rhombus, if I talk about pentagon, hexagon, all are polygons because they are made up of only line segments. Secondly, line segment concept clear? Closed figure. Why we have added an adjective before closed figure as simple? What do you mean by simple? Simple means not complicated. Then what is complicated or what is complex figure? Understand, simple means no intersection. No intersection. What do you mean by intersection? This. And understand, this is simple closed figure. I can brilliantly say this is simple closed figure. And it is simple closed figure. Now, if I consider this, it is not a simple closed figure because intersecting. This intersection makes it a closed figure but not simple. Closed figure but not simple. Are we clear? So, polygon, simple, closed figure. Very important. So, this is the closed figure but not simple. Last definition, that is of regular polygons. Polygons. Okay. Regular polygon having equal measure of sides. Secondly, measure of each angle must be same. Very, very important. It means that if 5 sides are there and the measure of each side is 2 cm, all the 5 sides must be 2 cm. If one angle is 60 degree, all the angles must be 60 degree. That is what regular polygon. Equal measure of sides, first condition. Equal measure of angles. Now, regular polygon, the smallest regular polygon is an equilateral triangle. Because all the 3 sides are equal and each angle is 60 degree. Then square in terms of quadrilateral. Then after that we use the terms like pentagon, hexagon, heptagon, octagon, nonagon, decagon, etc. Now, to present that this all are equal, we put a word regular before them. If I say regular, it means all sides are equal, measure of each angle equal. So regular, 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 regular. Now the condition for regular polygon, that is important. The number of sides, the equal number of sides is equal to number of line symmetry is equal to order of rotation. Do remember. For example, nonagon. Nonagon, regular nonagon means 9 sides. It means what are the lines of symmetry? 9. What is the order of rotation? 9. Now, what is the angle of rotation? 360 by 9? 40 degree. Are we clear? By this, the complete explanation of the chapter 14 symmetry is over. Are we clear? I hope you have enjoyed the chapter and you have learned the very new concepts in maths. Till then, take care and have a blissful day ahead.